Have you ever stopped to wonder why your world changes so dramatically throughout the year? Why one day is a sweltering afternoon, perfect for the beach, and another is a bone-chilling evening that calls for a fire? The answer isn't about our distance from the sun, as many of us were taught as children. The truth is far more elegant, more profound. It begins with a simple, quiet lean, a cosmic tilt that conducts the grand symphony of life on Earth. Stay with us as we journey from the gentle slant of our planet to the silent pulse of the cosmos and uncover how this ancient rhythm shapes not just our world, but our very lives. Our story begins with a quiet truth that shapes our entire world. Earth's seasons are born from a simple, elegant tilt of about 23.5 degrees. It's a subtle inclination, a slight celestial nod, but its consequences are monumental. This gentle lean governs the intricate dance of light and shadow across the face of our planet as we undertake our 365-day pilgrimage around the sun. Imagine holding a flashlight. That's our sun, and a small globe. If you hold the globe perfectly upright, the light shines most intensely and directly on its middle, the equator. But now, tilt that globe by 23.5 degrees. As you move it around the flashlight, you'll see how the most direct, concentrated beam of light shifts. When the northern hemisphere leans in towards the sun, it's as if it is turning its face to the warmth. The sun's rays strike it head-on, delivering concentrated energy. The days stretch long and languid, and the lands are bathed in the direct, warm rays of summer. 6 months later, as our orbital journey continues, the planet finds itself on the opposite side of the sun. Now, that same northern hemisphere is leaning away. The very same lands are now cast in the soft, cool, and slanted light of winter. The sun's energy is spread out, less intense, and the days are fleeting and short. All the while, the southern hemisphere is experiencing the exact opposite season, a beautiful planetary symmetry. This cosmic geometry is the silent conductor of life. It's a force more powerful than any king or conqueror, orchestrating the tender bloom of spring, the vibrant shimmer of summer, the melancholic retreat of autumn, and the deep, restorative slumber of winter. Without this tilt, our world would be a place of profound monotony. The climate would be locked in a perpetual state, a single, unchanging season stretching from pole to pole, year after year. The diversity of life as we know it, from the wildflowers that need a winter freeze to the crops that demand a summer sun, might never have evolved. It is this simple lean that gives our world its rhythm, its variety, its very character. The balance we experience is exquisitely fragile. That 23.5-degree tilt is a sweet spot for life. But what if it were different? Imagine, for a moment, a world tilted much more dramatically, say 45 or even 60 degrees. On such a planet, the seasons would become instruments of violence. Summers in the hemisphere, tilted toward the sun, would be catastrophically hot, with the sun beating down from almost directly overhead. For months on end, oceans would boil, landscapes would parch, and life would be scorched into submission. Then, just 6 months later, that same hemisphere would tilt far away from the sun, plunging it into a winter of unimaginable cold. Temperatures would plummet to levels that would freeze oceans solid and encase the land in a thick shell of ice. Civilization, as we know it, would be a constant, desperate struggle for survival. How could you build cities when they must withstand such violent swings in temperature? How could you practice agriculture when the growing season is a brief, frantic race between a deep freeze and a scorching inferno? Life might exist, but it would be relegated to the hardiest of extremes, and the rise of a complex society would be a monumental, perhaps impossible challenge. The delicate balance we enjoy, the climate that has allowed humanity to flourish, is held steady by a quiet, gravitational partner, our moon. Its presence is more than just a beautiful light in the night sky. It is the anchor that saves us from a fate of climatic chaos. The moon's immense gravitational pull acts as a stabilizing force, a cosmic gyroscope for our planet. It grips Earth's equatorial bulge and prevents our axis from wobbling erratically over the vast timescales of millennia. To understand how vital this is, we need only look to our neighbor, Mars. The red planet lacks a large, stabilizing moon. As a result, its axial tilt is chaotic. Over millions of years, Mars's tilt has likely swung wildly, from nearly upright to over 60 degrees. This chaotic wobble would have created devastating climate shifts, swinging the planet between periods of relative calm and the kinds of extreme, violent seasons we just imagined. Any liquid water that may have once graced its surface would have been alternately boiled away and then frozen into deep planetary glaciers. The chances for life to gain a foothold and evolve in such a wild, unpredictable climate are drastically reduced. The moon's steadying hand ensures our climate remains predictable enough for life to not just survive, but to truly thrive. It is a testament to an ancient celestial partnership forged in the cataclysmic origins of our solar system. Every season we experience, every predictable turn from spring to summer, is a quiet thank you to that silent, watchful guardian in our sky. Even with the moon's stabilizing embrace, our Earth is not perfectly still. It performs a slow, graceful wobble, much like a spinning top, as it begins to slow down. This movement, known as axial precession, is incredibly slow, taking about 26,000 years to complete one full cycle. But there's another, even deeper rhythm at play. Over a vast cycle of 41,000 years, the degree of Earth's tilt itself shifts, moving between roughly 22.1 and 24.5 degrees. This rhythm is part of the Great Milankovitch patterns, a set of cyclical orbital movements, first hypothesized by the Serbian scientist Milutin Milankovitch. He proposed that these long-term changes in Earth's orbit and orientation are the primary drivers of our planet as long-term climate, responsible for triggering the beginning and end of ice ages. This 41,000-year wobble is the planet's deep breathing, a slow inhale and exhale that has shaped the face of our world for millions of years. Let's follow this breath. When the tilt lessens, approaching 22.1 degrees, the seasons become milder. Crucially, the summers in the high-latitude regions of the northern hemisphere become cooler. They are no longer warm enough to melt all the snow and ice that accumulated during the winter. Year after year, century after century, the snowpack deepens. It compacts under its own immense weight, transforming into dense glacial ice. Over thousands of years, these small, incremental additions build the great continental ice sheets, miles thick, that advance from the poles and plunge much of the world into a deep ice age. Then, the cycle reverses. As the planet's tilt slowly increases towards its maximum of 24.5 degrees, the seasons become more extreme. The summers in the northern hemisphere get warmer. This extrasolar energy begins to melt the edges of the great ice sheets. The melt accelerates, and over thousands of years, the glaciers retreat, freeing the land and the water once locked in their icy grip. This is not mere theory. This ancient wobble, this deep breath of the planet, is etched into the very fabric of our world. Scientists can read this history in the layers of rock and sediment on the ocean floor, and most remarkably, in ice cores drilled deep into the glaciers of Antarctica and Greenland. 11. These cores are like frozen time capsules. Each layer represents a year's snowfall, and trapped within that ice are tiny bubbles of the ancient atmosphere. By analyzing these bubbles and the ice around them, scientists can reconstruct past temperatures and atmospheric compositions, creating a climate record that stretches back hundreds of thousands of years. And what they find is a clear, repeating pattern of ice ages that corresponds beautifully with the Milankovitch cycles. This silent, gravitational force has sculpted continents, carved out great lakes and valleys, and guided the rise and fall of entire ecosystems and ages. It is a profound reminder that even the most dramatic changes on our planet are often the result of the most subtle, patient, and powerful rhythms of the cosmos. Twice a year, in this grand orbital dance, the Earth finds a moment of perfect geometric symmetry. These are the equinoxes, occurring around March 20th and September 22nd. On these days, the Earth's tilt is angled neither toward nor away from the sun, but perfectly sideways. As a result, the sun's most direct rays align directly over the equator. The word equinox comes from the Latin for equal night, and for these fleeting moments, day and night across the entire globe are nearly equal in length. It is a moment of planetary harmony, a brief but profound point of balance in the ever-shifting cycle of the year. For millennia, cultures around the world have recognized this powerful symbolism. The spring equinox has been celebrated as a time of rebirth, renewal, and new beginnings. It was a signal for planting, a promise of the life to come. The autumn equinox, a time of harvest and gratitude, was a moment to take stock of the year's abundance before the onset of darkness. These moments of balance, marked by festivals and rituals, remind us that harmony in nature is not a static state, but a dynamic, ever-moving point of equilibrium. In stark contrast to this balance are the solstices, which mark the extremes of the cycle. Occurring around June 21st and December 21st, these are the days when one of the Earth's poles is tilted at its maximum angle toward the sun. The name itself, from the Latin solstitium, for sun stands still, beautifully describes the phenomenon from our perspective on Earth. If you were to track the sun's path across the sky each day, you would notice it rising and setting a little further north or south along the horizon. This path reaches its northernmost point on the summer solstice and its southernmost point on the winter solstice. For a few days around these dates, the sun's path appears to pause, to stand still, before it begins its slow journey back in the opposite direction. These moments, the longest day of the year in summer and the longest night of the year in winter, were humanity as first and most important clocks. They were the celestial anchors that grounded our ancestors' lives, anchoring their rituals, their calendars, and their very understanding of the world. The summer solstice was a celebration of light, power, and abundance. But perhaps more profound was the winter solstice, in the deepest, darkest point of the year. It held a sacred promise, Even after the deepest darkness, the light will always, without fail, return. This celestial guarantee of renewal became the bedrock of countless spiritual traditions and a source of enduring hope for humanity. Long before the invention of written calendars or mechanical clocks, ancient civilizations possessed a deep and sophisticated understanding of these celestial rhythms. They were not just passive observers of the sky, they were active participants, building monumental tributes to the cosmic cycles that governed their lives. These structures were more than mere buildings. They were bridges between the heavens and the earth, massive instruments designed to capture and celebrate the turning of the year. Perhaps the most famous of these celestial clocks is Stonehenge, rising from the Salisbury Plain in England. For thousands of years, people have gathered at this enigmatic circle of stones to witness a breathtaking spectacle on the morning of the midsummer solstice. As the sun breaks the horizon, its first rays align perfectly with the monument's central axis, shining directly over the outlying heelstone. It's a moment of profound connection, a tangible link to the Neolithic people who, 5,000 years ago, possessed the astronomical knowledge and engineering skill to create such a precise alignment. Archaeologists now believe the winter solstice sunset was equally, if not more, important to its builders, suggesting it was a place to honor the cycle of death and rebirth. Half a world away, nestled high in the Peruvian Andes, the Inca civilization created their own celestial observatory at Machu Picchu. Here, a sacred stone, known as the Intihuatana, often translated as the hitching post of the sun, was carved with extraordinary precision. During the winter solstice, the shortest day of the year, the sun's rays cast a specific shadow that aligns perfectly with the stone, a ceremony believed to symbolically tether the sun and prevent it from disappearing completely. In the Temple of the Sun, a uniquely carved window was built to capture the light of the winter solstice sun, illuminating a sacred granite stone within. These alignments were crucial to the Inca, whose empire depended on an agricultural calendar dictated by the heavens. And in the arid landscape of Chaco Canyon in what is now New Mexico, the ancestral Puebloan people left a more subtle but equally astounding marker. High on a butte, they carved two spiral petroglyphs behind three massive slabs of rock. For all but a few moments of the year, these spirals remain in shadow. But on the summer solstice, a single, brilliant dagger of light pierces directly through the center of the larger spiral. At the winter solstice, two daggers of light perfectly frame it, and on the equinoxes, smaller daggers appear in other key locations. This sun dagger was a remarkably precise and elegant calendar, a testament to a people who watched the sky with immense patience and reverence. These structures, and countless others, like them around the globe, reveal a universal human need. They were not just primitive calendars for planting crops. They were physical manifestations of a deep desire to find order in the universe, to feel a sense of place within the grand, silent, cosmic turning of the year. They were sacred spaces where the rhythms of human life and the rhythms of the cosmos became one. This precise celestial clockwork doesn't just govern the light and temperature of our planet. It is the silent beat to which all of life on Earth dances. The great journeys and profound transformations of the animal kingdom are intricately timed to this planetary rhythm. Consider the epic journey of the Arctic tern. This small seabird is the undisputed champion of migration, chasing 2 summers across the globe each year. It breeds in the Arctic during the Northern Hemisphere's summer, and then flies all the way to Antarctica to enjoy the Southern Hemisphere's summer, a round trip of some 50,000 miles. This incredible feat of navigation is guided by an internal clock and a sophisticated set of tools. Migrating birds use the sun's seasonal path as a map and compass, correcting for the time of day to maintain their bearing. They can sense the Earth's magnetic field and may even use polarized light at sunrise and sunset as navigational cues. They are not just flying, they are performing an act of celestial navigation that would rival any ancient mariners. These travelers connect the hemispheres in a living, breathing circuit of movement. Humpback whales follow the seasonal blooms of plankton and krill, journeying from their warm water breeding grounds to the nutrient-rich feeding grounds of the polar regions. Wildebeest in the Serengeti follow the rains, a constant search for fresh grazing lands driven by the wet and dry seasons. These are not random wanderings. They are precise, instinctual responses to the predictable, seasonal availability of resources. While some creatures respond to the seasonal clock with incredible journeys, others respond with a profound stillness. The North American black bear, for instance, times its hibernation not simply to the arrival of cold weather, but to a more reliable celestial cue, the shortening of daylight. This change in photoperiod triggers a cascade of physiological changes. The bear's metabolism slows dramatically. Its heart rate drops from 50 beats per minute to as few as 10, and its body temperature decreases. It enters a state of suspended animation, a deep sleep that allows it to conserve energy and survive the long, lean months of winter when food is scarce. From the monarch butterfly fluttering thousands of miles to find a specific forest in Mexico, a place it has never been, but is genetically programmed to find, to the salmon returning from the ocean to the exact stream of its birth, all life moves to this silent planetary beat. The seasons are not just a backdrop for life's drama, they are the very conductor of the orchestra. The seasons don't just dictate the actions of life, they also paint our world in a breathtaking cycle of vibrant color and evocative scent. These sensory experiences are not mere decoration. They are the outward expression of deep biochemical processes, a chemical language that speaks of survival, decay, and rebirth. The brilliant spectacle of autumn is a perfect example. The shedding of leaves by deciduous trees is a masterful survival strategy, timed with beautiful precision by the lengthening of the night. As the days grow shorter, a signal is sent to the leaves to cease production of chlorophyll, the green pigment responsible for photosynthesis. As the dominant green fades, it unmasks the other pigments that were present in the leaf all along, the bright yellows and oranges of carotenoids. At the same time, cool nights and sunny days can trigger the production of new pigments called anthocyanins, which create the spectacular crimsons and purples that set a forest ablaze with color. The tree is not dying. It is strategically retreating. It reabsorbs valuable nutrients from the leaves back into its twigs and roots, storing energy for the coming spring. The crisp, earthy scent that fills the fall air is the smell of this cycle completing itself. It is the work of billions of microbes, particularly a type of bacteria called actinomycetes, breaking down those fallen leaves. As they do their work, they release a compound called geosmin, the same compound that gives soil its rich, earthy smell. It is the scent of decomposition, the beautiful fragrance of life returning to the soil. Then, after the cold slumber of winter, the world awakens with another unforgettable sensory cue, the unmistakable smell of the year's first spring rain. This scent, known as petrichor, is a complex cocktail of chemical conversations. Over a dry spell, plants release airborne oils that settle on the soil and rocks. When the first raindrops hit the dry ground, they trap tiny air bubbles. These bubbles race upwards and burst from the droplet, releasing a fine aerosol that carries both the plant oils and that same geosmin from the newly awakened soil bacteria. The result is that fresh, clean, and vital scent of spring, the chemical language of a world reawakening, a conversation between light, air, water, and life itself. While many of us experience 4 distinct seasons, the expression of this celestial rhythm varies dramatically across the globe. It is at the top and bottom of the world, and along its middle, that the seasons reach their most dramatic and different expressions. North of the Arctic Circle and south of the Antarctic Circle, the tilt of the Earth creates a world of breathtaking extremes. During the summer solstice, the pole is tilted so fully toward the sun that the sun never sets. This is the land of the midnight sun, 24 hours of unbroken daylight. Life here explodes in a frantic rush to take advantage of this fleeting period of constant energy. Plants grow with incredible speed, insects emerge in vast swarms, and migratory animals arrive to feast on the temporary abundance. 6 months later, the same region is plunged into the deep stillness of the polar night. The pole is now tilted completely away from the sun, which never broaches the horizon. It is a world of twilight and darkness, a landscape frozen under a blanket of stars. Life here must be incredibly resilient, adapted to survive months of extreme cold and darkness. For many creatures, this is a time of hibernation or departure, a period of profound quiet and waiting. The seasons here are not a gentle transition, but a dramatic switch between all and nothing. Now, travel to the regions near the equator. Here, the sun's path across the sky barely changes throughout the year. The days are always approximately 12 hours long, and the temperature remains consistently warm. In the tropics, the seasons are not defined by light or temperature, but by water. Life follows the rhythm of wet and dry seasons, a pulse driven by a great atmospheric migration. This migration is caused by the intertropical convergence zone, a belt of low pressure where the trade winds of the northern and southern hemispheres meet. This zone shifts north and south with the seasons, following the sun's most direct rays. When it moves over a region, it brings with it intense, life-giving rains. When it moves away, the dry season begins. This cycle gives rise to the great monsoons of Asia and Africa, born from the simple fact that land heats up faster than the sea. In these tropical lands, the only seasons that truly matter are those of the sky's generosity, the season of giving rain, and the season of holding it back. If you could step back and view our planet from space, armed with instruments that could see the invisible gases of our atmosphere, you would witness the Earth breathing. Each year, our world takes one slow, deep breath, a planetary heartbeat perfectly synchronized with the turning of the seasons. This breath is measured in carbon dioxide, the fundamental building block of life and a key regulator of our planet's temperature. In the late 1950s, a dedicated scientist named Charles David Keeling, began making meticulous, continuous measurements of atmospheric CO2 from an observatory atop Mauna Loa in Hawaii. The data he collected, which continues to this day, produced a graph now famously known as the Keeling curve. The curve shows a clear, unmistakable, long-term rise in CO2 due to human activities. But it also reveals something else, a beautiful, annual zigzag pattern. This zigzag is the signature of our planet breathing. Each spring, as the vast, temperate forests of the Northern Hemisphere, where most of the world's landmass is located, awaken from their winter slumber, they begin to inhale. Through photosynthesis, the trees and plants draw in enormous amounts of carbon dioxide from the atmosphere, using the carbon to build their leaves, stems, and roots. This collective inhale is so massive that it causes global atmospheric CO2 levels to measurably drop. At the same time, in the world's oceans, massive blooms of phytoplankton, microscopic marine plants, perform the same function, drawing carbon deep into the sea. Then, in the autumn, the process reverses. As the leaves fall from the trees and the seasonal vegetation dies back, the process of decomposition takes over. The microbes in the soil go to work, breaking down the organic matter and releasing the stored carbon back into the air. This is the planet's great exhale. This annual pulse, this rhythmic rise and fall of CO2, is a powerful demonstration of how intimately the atmosphere is tied to the biosphere. Every forest, every ocean, every blade of grass plays a role in this global respiratory system, regulating the climate of our world. It is a breathtakingly interconnected system, a planetary scale dance between life and the air itself, all choreographed by the simple tilt of the Earth. Our tilted world is not alone in its seasonal dance. The simple geometry of a planet's tilt and orbit can create rhythms of unimaginable diversity, and a brief tour of our solar system reveals a fascinating gallery of seasonal extremes. These distant worlds serve as powerful reminders of how special and stable our own planet sea rhythm truly is. Let's start with Mars. The red planet has a tilt of about 25 degrees, very similar to our own, so it experiences 4 distinct seasons. However, its seasons are nearly twice as long as ours, because a Martian year is 687 Earth days. Mars also has a more elliptical orbit than Earth, meaning its distance from the Sun varies significantly. This makes the seasons in its southern hemisphere more extreme than in the north. But as we've seen, the real drama on Mars is its unstable wobble. Without a large moon to hold it steady, its tilt varies wildly over long timescales, leading to chaotic climate shifts. Now, let's venture out to the gas giants. Jupiter, the king of the planets, spins nearly perfectly upright, with a tilt of only about 3 degrees. As a result, it has almost no discernible seasons at all. The weather you see on Jupiter today is largely the weather you did see at any point in its year, a world of magnificent but monotonous storms. Saturn, the ringed jewel, has a tilt of about 27 degrees, again, quite similar to Earth's. It experiences seasons just as we do, but on a truly majestic and slow motion scale. Because Saturn takes nearly 30 Earth years to orbit the Sun, each of its seasons lasts for more than 7 Earth years. Imagine a spring that lasts for 7 years, followed by a 7-year summer. But for the most extreme seasons in our solar system, we must travel to the strange, blue-green world of Uranus. This ice giant has been knocked on its side, likely by an ancient collision, and has an axial tilt of about 98 degrees. It essentially rolls around the sun on its side. This bizarre orientation creates the most profound seasons imaginable. For 21 Earth years, one pole is pointed directly at the sun, experiencing 2 decades of continuous, unbroken daylight. Meanwhile, the other pole is plunged into a 21-year-long winter of absolute darkness. Then, as Uranus continues its 84-year orbit, the situation slowly reverses. These distant worlds, from the seasonless Jupiter to the extreme world of Uranus, beautifully illustrate that the familiar, life-sustaining rhythm we enjoy is a precious and perhaps rare cosmic circumstance. Today, the familiar, life-sustaining rhythm of our seasons is changing. The celestial clockwork remains precise, but the earthly response to it is being altered by a warming climate. We are, for the first time, witnessing a human-induced shift in the planet's ancient cycles. The changes are most dramatic in the Arctic, which is warming nearly 4 times faster than the rest of the planet. The ancient cycles of ice and thaw are being disrupted, with sea ice shrinking and glaciers retreating at an alarming rate. This doesn't just affect the polar bears. It has global consequences, altering weather patterns and ocean currents far to the south. Across the temperate zones, the signs are more subtle, but just as real. Spring is arriving earlier. A 2022 study in the UK revealed that plants are now flowering, on average, a full month sooner than they did in the past. This can create a dangerous phenological mismatch. Migratory birds, for example, might arrive at their breeding grounds at the usual time, only to find that the insects they rely on to feed their young have already hatched and disappeared. Allergy seasons are lasting longer as growing seasons extend, and farmers are facing new challenges as traditional planting schedules become less reliable. Autumn is arriving later, and extreme weather events like unseasonal heat waves or storms are becoming more common. Yet, even as we alter its present rhythm, the Earth keeps a faithful and exquisitely detailed record of its own history. The memory of past seasons is written in the world around us, in natural archives that scientists can read like a book. The annual rings of trees, a field known as dendrochronology, tell a story of past climates. A wide ring speaks of a good growing year, with ample warmth and rain, while a narrow ring tells of stress, a year of drought or cold. Deep within the ice cores of Greenland and Antarctica, layers of ancient ice hold bubbles of air from millennia past, providing a direct record of past atmospheric composition and temperature. And in the oceans, the layered skeletons of coral reefs hold a similar chemical record of past sea temperatures and conditions. These natural archives are a profound gift. They tell the story of the planet's climate, a rhythm that has endured through eons of change. They provide the context for the changes we are witnessing today, reminding us that every heartbeat, every breath, and every harvest is ultimately and intimately tied to the slow, beautiful, and now changing turning of the seasons. Our journey through the seasons has taken us from a simple planetary tilt to the very breath of the Earth and the far reaches of our solar system. We've seen how this cosmic rhythm is not just a backdrop for our lives, but the very force that shapes our world, drives the engine of life, and anchors our deepest cultural and spiritual traditions. The lesson in this grand celestial dance is one of cycles. Just as winter gives way to spring, periods of darkness in our own lives are followed by the return of light. The earth teaches us the wisdom of balance found in the harmony of the equinox and the necessity of both vibrant activity and quiet rest. Like the contrast between summer and winter, this rhythm of renewal is woven into the fabric of our being. So, my advice, or perhaps my hope, is that we can all strive to connect more deeply with these natural cycles. Maybe it's as simple as noting the changing position of the sunrise, planting a small garden to feel the soil awaken in spring, or simply taking a walk in the woods to witness the spectacular, strategic retreat of autumn. By attuning ourselves to the planet's rhythm, we can find a greater sense of peace, perspective, and belonging in our own lives. And now, I have a question for you. Which season speaks to you the most? And why? What memories or feelings does it evoke? Share your thoughts in the comments below. I'd love to read your stories. And if this exploration has sparked your curiosity, please consider subscribing to the channel for more journeys into the incredible wonders of our world. We have so much more to explore together.